Okay, now we're going to look at a couple more related rates examples. Here we have a police cruiser approaching a right-angled intersection from the north. It's chasing a speeding car that's turned the corner and is now moving east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? Now we can see again that this makes a right triangle. We know that we are looking at the situation when x in this case is 0.8 and y is 0.6. We're also told that the change in y, which is the rate at which the cruiser is moving, is negative 60. Now notice it's negative because as they are approaching the intersection, the distance between them and the intersection is decreasing. We also know that the change in s with respect to time is 20. The distance between the two cars is increasing at a rate of 20 miles per hour. And what we need to know is dx dt. We need to know the change in the rate of x, or the speed of the car that the police are chasing. Now, as we look at what our formula is here that we're going to be using, we have a right triangle, so we are going to use the Pythagorean theorem. And of course, the Pythagorean theorem in this case would be x squared plus y squared equals s squared. So that is going to be the formula we use that relates all three of these together. Now let's summarize again what we know. We know that the change of y with respect to t is negative 60 miles per hour. We know that the change of s, which is the distance between the cars, with respect to time is 20 miles per hour. And we want to find dx dt when our x is 0.8 miles and our y is 0.6 miles. And we just said the formula we want to use is x squared plus y squared equals s squared. Now we know the change in y, and we know the change in s, and we're looking for the change in x. So we have a formula for which we have our unknown rate, and we know the rates for everything for the other two. So we'll go through and take the derivative of each. The derivative of x squared is going to be 2x, and we'll also need dx dt. Plus the derivative of y squared is 2y, and we'll need dy dt. And then the derivative of s squared is 2s, and we'll need ds dt. Now as we look at this, we are looking for dx dt. We know x, we know y, we know dy dt, and we know ds dt. We are missing our s. And so we do need to find that information before we can plug into this formula. Otherwise, we will have two unknowns. Now we know that x is 0.8 and y is 0.6. So if we go back to our formula, x squared plus y squared equals s squared, and we plug in our 0.8 and we plug in our 0.6, that's 0.64 plus 0.36 is going to be 1. And of course the square root of 1 is 1. So at this point, when x is 0.8 and y is 0.6, then the distance between the two cars is 1 mile. Now plug in all the information we know. We have 2 times, we said x was 0.8, dx dt is our unknown, that's what we're looking for, plus 2 times y is 0.6, and dy dt is negative 60, equals 2 times s, we just found to be 1, and ds dt is 20. Now go through and multiply. We have 2 times 0.8 is 1.6 dx dt, plus, or this is actually going to be minus 2 times 0.6 times negative 60 is going to be minus 72. And then 2 times 1 times 20 is going to be 40. Now we're solving here just a linear equation, so we want to add 72 to both sides so that our 1.6 dx dt will be by itself. And so if I add 72 to 40, I will get 112. Now I want the dx dt by itself, so I'll divide both sides by 1.6. And when you divide 12 by 1.6, you will get 70. So the car that the police are chasing is traveling at 70 miles per hour. Now one other example here. We have a conical tank, and water is running into this conical tank at the rate of 9 cubic feet per minute. Now the tank stands point down and has a height of 10 feet and a base radius of 5 feet. We want to know how fast is the water level rising when the water is 6 feet deep. Now notice that they are using y for their height and x for their radius. So what we're asked to find is how fast the water level is rising, so that will be dy dt. And that is when the water is 6 feet deep, and that tells us we're finding dy dt when y is 6 feet. We also know that the volume is increasing at 9 cubic feet per minute. Now we need an equation that relates our x's, our y's, and our v's. Now normally when we do the volume of a conical tank, we do 1/3 pi r squared h. Now in this case, we have 1/3 pi, and they're using x for the radius, so the x squared, and they're using y for the height, so that would be y. Now notice that we know the change in the volume, and we know we're looking for the change in the y, but we know nothing about the change in the x. So we cannot just differentiate here, because then we're going to have a dx dt, and we don't know any information about that. So what we need to do here is we need to find this formula in terms of just v and just y. Now what you want to remember here, if you look back to your picture, is as you look at x, y, and you look at the 5 feet and 10 feet, as your radius and your height grow, they're going to grow proportionally to the relationship between the radius and the height of the cone itself. In order to find that, I can look at this and set up a proportion. So I can say x is to y as 5 is to 10. Okay, x is to y as 5 is to 10. We can cross multiply. And now I do not want to have any more x's. So if I'll divide both sides by 10, I know that x then is going to be y divided by 2. Well, if I know that, the x is y divided by 2, and obviously it is, our radius is our height divided by 2, then I can come back to this formula and simplify it. So I will have 1/3 pi, and x is y over 2, and I'll square y over 2. That gives me y squared over 4. And multiply together here, I will have on top pi, and y squared times y is y cubed, and in the denominator 3 times 4 is 12. So this gives us a formula that relates our volume and our height, or our water level. And again, the reason that I went through and I changed here from having x's and y's in volume to just having volume and y is because I do not know the information about how quickly our x is changing. Okay, so let's summarize again what we know. We know the change in volume, we know the change in volume with respect to time is 9 cubic feet per minute. Okay, we want to find the change in y, which was our water level, when y was 6 feet. Okay, so let's look at our formula again. Once we simplified, we had that the volume was pi y cubed divided by 12. Now what we need to do here is differentiate, so the derivative of the volume with respect to time, and we bring our 3 and subtract 1 from our exponent, and we'll also have dy dt, the derivative of y with respect to t. Now we can simplify this sum. Since I have a 3 on top and a 12 on bottom, that will give me pi y squared over 4 times dy dt. Okay, now I am trying to find here, I want dy dt. And I know some information, so I'll just go ahead and plug in what I know. I know the change in my volume is 9. I know that y, we're looking for when y is 6. Well, if I multiply 6 squared is going to give us 36, and 36 divided by 4 is 9. So this will be 9 pi dy dt. Now I don't want to know about I want to know about dy dt, so I need to get rid of the 9 pi, and I do that by dividing both sides by 9 pi. And so that will be 9 divided by 9 pi. Or dy dt equals, 9 goes into 9 one time and into 9 one time, 1 over pi. If you type that into your calculator, that is approximately 0.32. And we were looking at feet, and it was measured in minutes. So the change in the height is 0.32 feet per minute.